Hello everyone. In this video we're going to talk about moments, which you may have heard them called torques. So engineers tend to call these quantities moments, physicists call these things torques, and they're often denoted by m or a tau for the torques. So by the arrow on top you can see that these are vector quantities. So all the vector mathematics, all the vector properties that you've seen before, dot products, cross products, components, addition, subtraction, etc., can be applied to these vectors. So what do these things do? Let's start out with a little conceptual description of this. So these things cause rotation about an axis. So rotation of what? So it's typically a body, right? I'm going to rotate some body about something. And this thing is created by a force, which is another vector quantity. Offset relative to a point. And say which we'll add in space, because I'm going to draw everything on 2D, but conceptually everything, of course, applies in 3D. So let's see an example that you're quite familiar with. Let's take a door. So we'll draw a simple model of a door. It's rotating about some axis, right? Here. So these hinges are about something. And if you want to open the door or go through it, you're going to push on it with a force. So let's take a top view and see what happens when we change the position of the force or the angle of the force. So in some case, as you have probably experienced, I'll just draw now the door as a line. If I push on the end, here's the hinge, or here's the axis. So we're talking about an axis. This is the axis here. It's going to rotate about this axis. This is the body is the door. If I push on it with this force, this is going to rotate, open up, and the door of the body rotates about the axis. At some point you've probably approached the door at an angle and pushed on it. Probably still opened. I would imagine you found it a little bit harder. And at some point, you may have even tried to open a door in a direction parallel to the plane of the door. And did that open? All right, so here, in terms of opening, this was easiest. This was harder. This did not open, right? So it didn't open. All right, so go test this out now. Whatever room you're sitting in, stand up, walk over to the door, and push it at the different angles. So dead on, perpendicular, at some angle, and parallel to the door itself. Okay, so this implies that the moment depends upon, so the moment is how much sort of, how easy it is, let's say, to open the door. So it sounds like if I increase F, it's going to be easier to open the door. That makes perfect sense. It has something to do with angle, and it also has something to do with position, right? So if I push on the door with this force, or push on it with the same force but at a different location, it's going to be harder to open the door. Right? So when we look at the definition of a moment, I'm going to give that as m. So it's a vector, so I'm going to write a point with respect to all right. So whenever you write a moment to be complete, you must describe it with respect to some point. And this is going to be R cross F. Okay? So in a moment I'll describe exactly what those vectors are, but if you go back and recall what you learned about vectors and evaluating the cross product, this quantity is the magnitude of R times the magnitude of F times sine theta. Okay? And theta is the angle from R to F R and F are let's see, so R and F are tail to, I'll put it this way, tail to tail. And I'll draw a picture in a moment. I'll just go to the next page and draw this. Go tail to tail. So that's going to define how we define this angle. And we're missing one thing, right? These are vectors. So here, I'm going to call U, I'll put a U hat. So this is a unit vector, which is perpendicular. So the direction is perpendicular to the plane defined by R and F. Okay, so, and the positive direction defined by the right-hand rule. Okay, so let's go over that in a little more detail so you can see what all these things are. Okay, so the moment, let's just rewrite this at the top. The moment of this point is R cross F. And magnitude, sine of the angle between them. Okay, so if I have a point, I have a force. Okay, so R is position vector. From O, that's the point in question, to tip, or not tip, the tail of F. Right. So we have a vector. It starts somewhere. This is the tail. I'll call this the tip or the head. So this vector is R. Okay. All right. So if I put these things now tail to tail, right? Because we said, what is the angle theta? This is the angle R to F, the angle of R to F when tail to tail. Okay, so this is tip to tail. I'll just draw this through, put the tails on top. I can just pick up this vector and move it in space. Now the tips are together. So this angle R to F is the angle that we want. Okay. All right. Where is U? U is unit vector. So magnitude is 1. And its direction is perpendicular to the plane defined by R and F. Okay, so in this case, F lies in the plane of the paper, R lies in the plane of the paper. They define the plane of the paper. So it's perpendicular to that, either coming out of the page or going into the page. And the positive direction follows the right-hand rule. Okay, so what do we mean by that? Right-hand rule. Take your right hand, point your fingers in the direction of the first vector. So point my fingers in the direction of R, curl them to the second vector, F. My thumb will point in the positive direction. So I place my fingers in the direction of R, I curl them to F, which is the second vector. My thumb points upward, that's the positive direction. So U, in this case, I'll draw this such, comes out of the page. The positive direction is coming up towards the camera. So let's put this here. All right. So that'll tell us what the, will allow us to calculate the moment. So this is the magnitude of the moment. And this unit vector gives us its direction. Okay, so let's do a check here. We said in our previous case, that this was the easiest. So this, in a sense, is generating the greatest moment. This is generating no moment, right? Because it's not opening the door at all. So let's check and see if that is the case. So as R increases, as R increases, so in this case, this distance is R, right? This is the point that we're talking about, moving all the way out to the point of application of F. So let's redraw that. If I'm looking at this case, I'm going to draw F going through here, just so I can get the tail a little bit easier. This is the point in question, so this is R. If I increase R, then the moment increases. Makes it easier to open. Okay, that makes sense. Verifies with our experiment that we just did. If F increases, if I push harder on the door, pretty obvious, it's easier to open the door, so the moment increases. Check. All right, so the angle here is 90 degrees, going down to 0 degrees. So that means sine of 90 going down to sine of 0, right? So sine of is 1, the largest value going down to 0. So the moment goes from large, let's see, large to small. So that checks, right? So when our angle here, R cross F, I push it through so the tails are together. This is the angle theta. When theta is 90, this is large, moment is large. When it is 0, the force going in 0 the same way, then we have 0 moment. So moment goes from large to small, in fact small being 0. So that checks out. All right, so with that, last point that's important here is that keep in mind, as we said for vectors, order matters. Right? Order, cross product order matters. So R cross F, is that equal to F cross R? If we look at our expression here, the magnitudes will be the same. Theta, so this one, let's write that out, R, F, sine theta. Is that equal to R, F? So what is our angle now? It's angle from the first one to the second one. So it's this one to this one. We're going in the minus direction. So I can pull the minus out front. So they're different. Turns out that the magnitude is the same. And then the only difference is the difference in the direction. So if I say R cross F, positive is coming out of the page. If I take F cross R, so F crossing to R, my thumb points into the page. Put it down. My thumb points into the page. I'll have an opposite direction. So when you take the cross product, the order matters.